Yeah. something positive. Yeah. When? What? You know what time is it? We should start 10:15. Now it's 10:21. Scan your code and take your codes. Anyone else? You know what is this discipline? Next time, I will close door 10:16. Okay. Now, what and why? What we are talking about here and why? Just, I'll say, disclaimer. My communication isn't best, and my idea, what's in English, I'm 100% sure differs from you. Yeah? If you don't understand something, please raise your hand and ask. Yeah, I'm starting to agitate. So if you don't understand something, raise your hand and ask, because my English is different from you. It's 100%. Once I was a fool, I thought what right pronunciation is on BBC broadcast. Yeah, BBC broadcasting is the right communication. It what should be. Now you see a result. Okay. So I want, if you don't understand me, raise your hand. Oh yeah. What are you talking about? Now what I'm talking about, what is theory of signals? Okay, theory is a blah. It's 100% clear. But what is signal? Theory of what? And why it's in your program? What's your main specialty? Adaptronics? Yeah. Adaptronics. Why signals is in your adaptronics program? Answer. Theory of signal, general communication guys are there. Here my specialty is power engineering and more special power system protection and fault location. Why I'm teaching theory of signal? Why I'm on power engineering? What's the if we open this Pandora box called electrotechnics? Electrotechnics starts with basic electrotechnics theory, yeah? Next one is theory of circuits, yeah? Theory of signals goes after theory of circuits. So, signal, I will write multiple times. S as a function of time. Anything we can observe in time. We can observe voltage, we can observe current, we can observe power, we can observe number of students as a function of time. Any physical level observable in time is a signal. Power engineering relies on a signal theory. Relies on the signal theory when we need to deal with something more complex than a sim or DC or AC. I'm speaking about what is theory of signals. And I need to say one thing. See all these cameras. We are live on YouTube, so if you miss something, you can watch this lecture later as many times as you need. And may recommend it to friends. It's freely available. I put a link to learning system. See, number of students increased. I can draw nice chart. Okay, next. I will use multiple terms on signal. If they are, how to say, discipline specific, I will go out of the classical electrotechnic sandbox. I will use ideas bit out of the box. Don't worry. What I'm talking about. First, I will use term determined signal and stochastic. You know what is stochastic? Or probability. What's a probability? Possibility? Yeah, of something. See, idea. For example, here is microphone recording my lecture. Can we predict signal where next minute? If signal is determined, I do have a mass description for it. I can tell value of my signal for any time moment starting from the creation and up to the doomsday. Signal determined if I have exact mass description for it, and I can predict it for any time moment in future or in past. probabilistic or stochastic signal is much more, how to say, murky object. I only, how to say, here's magnitude of my signal. I only can speak about its probability. Possible I have distribution chart. So if we take a look, we have what we have on this voice recording. I'm saying nothing. What I will hear? Oh, my clock is ticking. It's a lower level. Opposite, door opens and I don't know, bunch of clowns. It's a higher level. Reality will be somewhere between. In my business, in power systems, we usually try to use determined test signal, substituting this probability, because operation in probability area isn't, how to say, a pleasant task. Much better, much easier is to work with determined signals. One of the things we do, see, basic system safety of operation requirements. Our devices should withstand emergency regimes. If device has a rated current of 5 amps, it should withstand 240 times for 5 seconds. It's a safety requirement. Nothing should burn, nothing should explode in case 40 time current flows within 5 seconds. After 5 seconds you can burn it. So, if my device can function at 200 amps, it will be operational in any real situation. Here is my, how to say, top requirement. I need to withstand 200 amps for 5 seconds. I can use it as a test signal. If I have all my tests here on my papers, signed, tested, approved. My device is operational 5 seconds, 200 amps. It will be operational in any real situation, in any real case. Well, no one can tell me nothing. So it's it's a usual practice to substitute a real probabilistic signal with a test signal ensuring operation capability. Good. Now, next moment. So, determined signal. I have mass description, probabilistic or stochastic. I knew something about probability. Next thing. There are periodic and non-periodic signals. If signal repeats itself, within a repetition capital. Here m is an integer. What I'm doing? 0, 1, infinity. So here m is an integer, and t capital greater than 0 is a repetition period. So if signal repeats, we are dealing with periodic signal. Periodic signals repeats. It's aperiodic signal or non-periodic. This one was periodic with repetition period E capital Can you sleep longer? You know when we start? 10, 15. Now? 10:33. Can you sleep longer? Take it. Have you scanned your phone? You scan.
I don't have it.
You don't have an NFC chip, okay. Okay, take your colleague. Nice signal. Something familiar?
Oscilloscopy. Isn't it? Right.
Yeah. Something decaying. When you can see such signal, pulse. What it can be? Switch at time t0 and here you want this will be ground. Capacitance resistance. Ah, something familiar now. Capacitor discharge. Here, time constant will be 1 divided by x. It's a determined signal. I have a mass description for any time moment. This is when t greater or 0 n is 0 and time less than 0. It's determined, but it never repeats. Non-periodic or aperiodic signal. Familiar? Usually electronic students had some radio background. Or I'm wrong? Only basic electrotechnics. No radio circuit before. So this one is new for?
Yes.
Oh, only say only continuous circuits without switch.
Yeah, without switch.
Okay, I'll bring switch. How it can be without switch? Switch, nice. Know what this? Appears like a maze, but it's a switch star triangle, star delta connection for motor. Is there any manufacturing? No. Unreadable. It's from somewhere from 60s. Okay. What I'm doing? I can do one thing. For example, I can find a generator reducing sequence 1010 with a period of t capital and use it to drive a switch. Switch on, off, on, off, on, off. What will I get? 1, 2, 3. With the period of this time source. This will be pulse sequence. Sequence of pulses. Each pulse itself is decaying exponent. But all together they form kind of periodic signal. Pulse sequence. Pulse, we can consider what pulse sequence, we can treat pulse sequence as a periodic signal, but we should understand what here is a point of interruption. How to say, with caution. Pulse sequence. Artificially created periodic signal. Next. Next. What's next? Next, let's say I have an experiment. Say I got voltmeter with my experiment. I'm lazy, I don't feel to take observation by myself. I catch one student. Hey, you, bring me a table of values. What will I get? Sheet of paper. Number 1, 2, 3, oh, it's enough. Time, 1 minute, 2 minutes, let's say 3 minutes, and voltage in volts. I don't know, 5, 7, 3, something like this. Yeah? What I got in reality? I don't know, maybe like this changed my voltage. But I got measure. For simplicity, I can assume it's a tau space between measurements. Number 1, number 2, number 3, number 4. What this table represents? It appears what it's some derivative from the original white line, yeah? But what, for example, I don't know, 1.5 seconds. What was the value of my signal? Maybe this one, and maybe something like this. I don't know. And nobody knows, not measured. It's gone. Problem with my red line, all this red line represents signal as a function of discrete time I tau, that I, 1, 2, 3, integer, or discrete time signal. Between these measurement points, signal is, what should I write? What is signal? 0? No. Unknown. Between measurement points, signal is unknown. Discrete time signal. My time, our time. Each minute can be split in seconds. Each second in milliseconds, each millisecond in nanosecond, and so on. Our time is continuous, it's uninterrupted. This time is discrete. Why I'm talking about this? It's a time of digital system. Computing time, digital systems do have discrete time. It's always a minimal, time quantity between unknown, non-determined, unknown. For digital systems, for computer-driven system, for microcomputer system and so on, time is discrete. Our time is continuous. Signals we This in our space are continuous. For digital system, time is discrete. It's known, unknown, unknown, known. I know, unknown, known. Unknown, 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 known. And sometimes heavy discrete mass should be in. Okay, so discrete time. Signals of discrete time. Signals exist only in some determined time moment. One more small group of signals. We often deal with signals like this. Cosine of sine, where omega is double E divided by pi. What is? What has this formula? Ideal voltage, ideal AC voltage, ideal AC current. Such kind of signals are known as harmonic. They are determined, they are periodic, and they are very, how to say, handy. It's easier to operate with such kind of signal. Sometimes it's enough to perform calculus for one period if we have 50 Hertz. Do we have 50 Hertz? Oh, sometimes we have 60. Best life is in Japan, where north part has a 50 and south part 60. You know what Japan power system is split in two? Yeah, Japan's power system is split in two. Upper part close to European standards and lower to United States. If we have 50 Hertz, here we have, I expect we have 50. The period will be 20 milliseconds. Voltage will repeat in 20 milliseconds. Okay, what I got here? Do I got something? Sine or cosine? This sine or cosine? There is no difference. Shifted cosine will be a sine. Okay, this one is as sine what I'm changing?
Frequency,
Frequency or
amplitude.
period? No. Amplitude remains the same. I'm changing frequency in hertz will be 1 divided by period, or angular frequency. I'm changing frequency on period. Frequency increases, period decreases. Now I'm changing amplitude. Amplitude. larger amplitude. Okay, this is nice toy, but can I see signal? Here is one, but can I see? Can I get my signal visual? Would be nice. How can I do it? I need something. Maybe signal is harmonic, and maybe not. Maybe it's corrupt. I'd like to see my signal. Do something. Go, wire. Oh. I got something. One interesting toy. One Cruz, Professor Cruz, created a set of them objects for physics. I managed to obtain one. I'll switch this line. Oh, good. Can I get it bigger? Oh, here is my toy. What's the idea? I have evacuated vessel with high tension source applied, plus, minus. What can happen? What physics teach us? If we apply voltage high enough, electron may escape cathode and start travel towards anode. Here. Here is my ball electron. Crookes placed a die here. It's cut like this. This creates quite a flat beam of electrons. Next object, this white screen. White screen is covered with zinc sulfide. One could think with this zinc sulfide, if you put it under bombardment of electrons, it will glow with the visible green light. So we can see place where the electron beam is landing. What happens? Because force of electron is a current, and current in magnetic field means force. And electron beam is deflected. Classics of physics. Later it should be shown with Steltron tube. Your physics teacher showed you? Why? Sure. Any school should have it. Okay, bit deeper. And what's deeper? Crookes in its design, placed, here they are, two electrodes, two flat disks. What if I charge this one, upper one positive and lower one negative? What physics teach us?
Do they make superposition like?
Electron has a negative charge.
Yeah.
If we put it positive charge attracts it, negatives pushes away. So electron beam should
Yes.
go up. If opposite polarity should go down. If I apply a voltage, voltage, up from generator. Please. Okay, I think this one will be good. Where's my... Oh. See? AC voltage. Yeah?
So if we rotate this,
Yeah, I generate.
like,
The generator is slow, so I'm generating an AC voltage.
yeah, and if we rotate
Apply
it
it
five,
to my electronics beam.
yeah,
My electron beam. It's not an electron, but it's an electron beam. What will happen? Follows. You see? My beam follows AC. Can you see it? Stands steady,
yeah.
follows the voltage. What can I do? I can go to my shelf and find this object. It's a cathode ray tube, CRT. This part produces electron beam. Here, I'll bring close to camera, this one. Set of deflection plates. One here, another one forward. They form a kind of square. X1, X. Allowing what to operate electron beam both in horizontal and in vertical direction. One set at another one here deeper. And screen of zinc sulfide where my electron beam will land. Here is attachment for positive voltage. Negative attachment is in base. Cathode ray tube. It's cold. I like this old behemoth. It's an CRT based scope. it's better to show on all the CRT model. Digital models are not so it's made in 1969, yeah, 1961, but still operational. CRT scope has two channels. Horizontal channel and vertical channel, both are connected okay. Oh, here is my beam. I can, one second. Oh, hey, camera, please. Oh, can you see it?
Yeah.
I have low frequency signal on horizontal channel and electron beam follows. Left, right, left, right, left, right. Vertical, now I'm activated vertical channel. And it goes up, down, up, down. It's a scale. His possibility to, it's a controlled amplifier. I can implement scale. Horizontal movement. Vertical movement.
Professor,
Yeah.
is it like goes up and down because of AC current?
Yes, because of, let's say AC voltage.
Yes.
Yeah, AC voltage applied to vertical set of deflection plates.
Like I mean, cathode becomes anode and anode becomes cathode. Right? Is it?
Yeah, 1 second, I will attach one more generator. Or maybe something like, oh, see this? Design here. Horizontal plates, vertical plates. Now I'm activated vertical channel, so it follows signal from my, I have two generators, now it follows signal from lower generator. 1 second. More generators to the gut of generators. Here is my second. I will set something around. Oh. 400. Now I have vertical movement with, I'm expecting frequency 400 Hertz. And for
So right now you connect both of these, yeah? Vertical and
Yeah.
horizontal.
Maybe like this. Vertical. Okay, this is. Now I have connect upper generator powers vertical channel and lower generator powers horizontal channel. 1 second, I will try to set equal frequencies. Figure rotates with the frequency, or it's how to say differential frequency. It's a difference of frequency between two generators. Maybe I can turn my camera to make my setup visible. Here, what's the name of this figure? Research. It's a name of the research figure. Results when two. Here I have two harmonic signals with close frequency working simultaneously. I can use, for example, something classical 8. Here is horizontal frequency is 400 Hz and vertical 800. Classics of research figures 2 to 1. It will slowly rotate because frequencies are not 100% equal. Actual figure is flat. It's your mind make it rotating. And rotation directions is depending on angle. Okay, maybe I can go in opposite direction. 200. Yeah, vertical 200, horizontal 400. Or something interesting. $300 and $400 horizontal, $300 vertical.
Professor, can we see it in a low frequency, like?
Like?
Yeah, lower than 50 Hertz, and how it's
The same. No problem. I will show it. Let's see, maybe increase. Oh, too much. It's not. Difference is not in frequency itself, but in frequency ratio. If you speak on research figures, key moment is XY ratio. Try to find something. Something. What I got here? 1020, 1200. 1200 against 400. Funny research figure. But what if we take a deeper look? Can we look deeper? What do we see in the reality? If we, they are not our students. It's typical for us to draw a chart. X, Y being some function of x. Yeah? It's typical for us. I don't know something. Blah, blah, blah. What we see here? What is x? It's a chart. Why not? See, I have coordinates here. It's a chart of something. What's on horizontal? What's here? What's on x? X, 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 X. Oh, it's a signal. Number one. Signal from lower generator. So X is signal 1. And what is Y? What's a function of? What do we see?
Is signal 2.
Second signal.
Yeah.
But drawn as what? As a function of what? Yeah, of signal 1. We see actually signal 2 drawn as a function of signal 1. Represented, second signal, signal of this generator, upper, represented as a function of lower signal. Research figure in reality is a representation of Y channel signal, applied to Y channel, as a function of horizontal first channel signal. That's what we see in reality. If this signal will be a time function, we will see input as a function of time. If it is something different, we see our signal represented as a function of something different. Idea, if you have S1 something like this one is correct. You will get, can I activate my scope? And now more scopes to go to scope. Why? Who's here? Can you see? It's attached to this generator. It's not important. Here is signal of the lower generator. 1 second. it's use blue line. What we see on scope and here. It's a horizontal movement signal of the scope. Bit strange, bit non-linear. And stranger, it's, I don't know why, but it goes out inverted. I think if we make, no, not seen, this scope has a bit strange design. You see, it goes in opposite direction. So, strangely, movement to the right means not decrease of voltage, but increase. Strangely, it has negative, maybe it has, this signal is from driving stage, and output stage is inverted. That's why it goes down, not up. In theory, should go up, but here at output, from driving stage, it goes down. So, like movement is not from the left to the right, but in opposite. I don't know, maybe it has switched connection of plates. Something like this. This one is X1 and this is X2. Plates are in opposite. And driving is with negative signal will be this way again. I don't know why, but case it's I will try to get both. I'm changing time scale. Oh. Here. Can you see? I'm changing time scale of my scope. You can see.
If you increase the period of the signal, it...
One moment. Signal, from which signal? Inner signal of scope or observed?
This one that you...
I'm not changing observed signal. I'm changing time base.
Yeah.
So, okay, I need faster change of time signal on X if I want to see my observed signal in small scale. Now, 10 milliseconds per division, 100 milliseconds per division. Ten, 100. For each division, 100 milliseconds, 10 milliseconds. You can see change in time base. So, research figure drawn from time function works fine for us. We can get view of signal in time. Oh, camera, please come back. I will not hurt, but please. please show us camera. I'll be unhappy. Yeah, here is two scopes. One more moment. One more moment.
Professor, can we assume this one is S1 and this one is S2?
Yeah, this one is S1
Yeah.
and S2 coming from the generator. S2 is a sign. This one generator is a source of harmonic signal now. So S2 comes from generator and S1 is triangles. Only one and negative. I would like to show one more. One more thing. Come on, do the slide. Second, I need to catch. Oh. Oh, that's what I'm willing to show. See, it's sliding. There is one problem. I need, if I do nothing, slide between S1 or time base and S2 leads to something like this. Running image. I need to do something to make my image steady. It's idea of synchro circuit or synchronized. Observable white is my observable signal. I need to. I'd like to see it perfect, steady. See, it runs now.
Yeah.
I've disabled a synchronization circuit. Idea, all normal scopes has a synchro circuit. Case threshold voltage, I can change it on. Now it's near disabled. Idea is what? Time base activates when threshold voltage now it's above signal, yeah. Wait a moment. Shift. See, I'm changing threshold voltage. You see, it sets as 0 point. see threshold voltage, when to start, where the 0 point is. So to create a steady picture, synchro circuit is required. Without it, image will run synchro circuit. Okay, do I have time? Yeah, I have a bit. I have a bit of time to show one more element of theory. Not ideal. See, it's not ideal straight. And do you see the difference?
Yeah.
Here the period is a bit different at the end because scope is not perfect. This voltage should be straight ideal. Okay, it was a cheap scope at the day of birth. $1974. But it works. One more. One more theoretical switch. This one also needed moment. One more element of our theory. One more element, because it is one problem. Even when we deal with simple periodic signal. It's always a question, what's the damage, what's the price, and also which one is bigger, which one is stronger.
This one.
How to evaluate? Not so easy. One has a high amplitude, the second one is wider. Shaky ground, isn't it? We need some criteria to evaluate signals. And one second, I will show one of the very well based ideas. Okay, let's assume we have simple periodic determined signal where m is an integer and which one? 5 and 0 less than infinity. Simple periodic signal. How can we evaluate it? Let's say my signal, I can load it with resistance. Yeah? Resistor will heat. We will have some thermal power. I can put it in a calorimetric vessel and measure this power. Nice. What I can do? Well, I can take an ideal DC source and load it with the resistance. I will get definitely some thermal power. Yeah, it will heat. If these power are equal, I can say what in energy, looking at an energy source, the resources are equal. I can evaluate my strange signal, my complex signal, with equivalent DC source. When you go, I don't know, to buy potatoes, how it works? Weight of potatoes is compared with known weight. Here is 1 kilogram. We have national standard of kilogram, so if I ask for 1 kilogram of potato, what it will be? How? Some amount of potatoes equivalent in mass to weight of 1 kilogram, yeah? I have? No, I don't know. I need to ask for gold. We have a 5 kilo. This size. So here, if powers are equal, this DC source is an equivalent to my signal. As much 1 meter, 2 meter, 3 meters, as much measured, one more energy meters. As much is measured how? In price of energy. What's the E divided by resistance will bring me what? Current multiplied by E, so E squared divided by resistance. Easy. Easy. And what about my signal? Instant power of my signal will be S squared by time divided by R. Yeah? Correct? Correct. Within one period, what amount of energy will it spend for heating? Within one period, we will have from 0 to time S squared time 1 divided by R. And integrate in time. Correct? It's amount of energy within one period. Correct? Correct. This will be in joules. And what it was watt? How can I get power which shows watt meter? Power in watts? Energy in joules or in watt seconds. So, if I want watts, I need to divide amount of energy by time in which this amount of energy I got it. So I can write P1 as 1 divided by PR 0 to time S squared time in time. Cut. No crime here. I think no. But So E squared divided by R is equal to 1 divided by TR from 0 to time, S square of time in time. Blah, blah, blah. E square root 1 divided by time should integrate from 0 to period S square. Something familiar? Ooh. The name for this is signal effective value, or in English often RMS from root mean square.
Yeah.
RMS value. Take or take some meter, what's a true RMS multimeter. Pretends to show this value RMS or effective value. It's what's in. Now we can say what it's showing, what it pretends to show us when it writes R at U true RMS. What it show? What you're showing us? Now it shows. Now it shows buy me a friend, buy more multimeters. It shows DC voltage or current producing same amount of energy or bringing same amount of energy as my signal. Understood?
Yeah.
Yeah. So effective value of my signal or its RMS it's an DC voltage or current producing same amount or bringing to me same amount of energy. If you compare signals in RMS, it's a good base. Okay. Not all methods are showing this RMS value. We will see. Okay. What's next? What's next? Do we have someone online? No, they disappeared. Maybe some questions? We have next one, 12:30, yeah? Second one. Start now, or maybe better to do it in time. It's okay with, okay, I'm not going too fast. No? Okay? Signal. New word in acoustics. one microfarad. Oh, with this part all clear. Fine. That's all kind of false sequence. You know what I'm thinking? I think we can just take a bit longer break and start on time. Our next I will assemble a couple of networks. We'll try to see
Like the recordings will be available in the orders, right?
yeah, recording currently we are on YouTube. I'm putting direct reference to YouTube videos on a learning system, but they are on YouTube, and you know it's strange, but sometimes quality is higher when you watch directly from YouTube.
Okay.
And anyway, I will put. You can check. Previous year is available on YouTube, and this one also, all lecture will be on YouTube. To review, maybe I don't know, maybe something. To say, some problem prevents you from visiting lecture. Yeah, one more thing I almost forgot about how to close this course. I have 3 tasks
Okay.
for my foreign students. So if you need to get rid of me, solve 1. If you need high mark, solve 3. Okay? I put them on a learning system.
So we can start doing that one.
Yeah, you can. In theory, you can start to do it tomorrow,
Okay.
or maybe wait couple lectures to understand what to do.
Okay.
And please do not send me a chat GPT or something like this results. They are, how to say, it's a product of brainless to say it. Brainless it. Don't make how to say I will become angry. This may lead to heart attack, so don't make my sorrow. Do not send me a chat GPT results because they really make me mad and angry. It's an absolute, as many I sold them, they all were starting from ridiculous and ending to, how to say, product of drug addict, brainless it. Think, brainless. So please, try to think with your own brain. Okay, what we can take a break till 12:30. Yeah?
Yeah.
Oh, I don't understand military time. And I will speak on transfer ideas. I will try to speak on simple circuits and make some